Every major robotics company is building the same thing, a humanoid robot. Tesla has Optimus, Figure has Figure 02, and Boston Dynamics has Atlas. Billions of dollars and thousands of engineers are converging on this single form factor. But we need to ask the question, why? Is the human form truly the best way to move things? Or is it just that everyone else is doing it? If you designed a robot from scratch, with no preconceptions, what would you build? Would you build something on two legs struggling to balance? Or would you use wheels that are faster, stronger, and far more energy efficient? Today, we're questioning this assumption. We'll explore if the humanoid is the best solution, or just the most seductive story. Before we challenge the humanoid idea, let's understand why it exists. There are two main reasons. First is infrastructure compatibility. Our world, from doors to tools, is built for the human form. A humanoid robot can navigate a human factory without expensive retrofits. That's why companies like BMW are testing them. It's a compatibility play. The second reason is psychological trust. Studies show people respond better to robots that look more human, feeling like they have a partner, not a replacement. But this is where the industry gets stuck. It's adapting the robot to our legacy world, instead of asking if that's the most efficient solution. That isn't engineering, it's groupthink. The question is not if humanoids can work in our spaces. They can. It's whether we should design robots for old infrastructure or new infrastructure for optimal robots. Let's look at the hard truth, starting with physics. The energy cost of transport for Boston Dynamics Atlas is around 3.3. For humans, it's 0.2. For wheels, just 0.01. This is a fundamental efficiency gap. A wheeled robot moves faster, carries more, and runs longer. And Boston Dynamics knows this. Their actual commercial products are Spot and Stretch, which are not humanoid. Atlas, the viral star, has never been sold as a product in over a decade. Impressive isn't the same as useful. Real-world deployments tell a similar story. The Figure 02 robot at BMW performed a specific task but needed frequent human help. Amazon's and Mercedes' pilots are still in early stages. Meanwhile, over 1,500 Spot robots are in the field doing real work. And, in 2024, over 542,000 non-humanoid industrial robots were installed. The real market data points away from humanoids. Then came a plot twist from Google DeepMind. They did something that suggests the entire humanoid theory is backwards. They took data from 22 different robot types: arms, quadrupeds, wheeled bases, and even drones. Then they trained a single AI model called RTX on all of it. The result was stunning. This universal model performed 50% better than specialized models. This is the future. Not one universal body, but one universal brain that can operate any body it needs. This concept is called morphology-agnostic robotics. It makes the big bet on humanoids seem obsolete. The universal worker isn't the body. It's the brain that can pilot anybody. This is the outcome of applying first principles instead of following the crowd. We predict that in 5 years, the humanoid robotics boom will have collapsed. Companies will pivot or fail, and people will wonder how they got it so wrong. The answer is simple. They followed a narrative instead of the data. They optimized for a flashy demo, not for what works in the real world. The companies that win will build morphology-agnostic systems with a universal intelligence. One brain, many bodies. That's not just more efficient, it's smarter. The future of robotics isn't one type of robot. It's a universal intelligence operating many specialized bodies, each optimized for its task. Humanoids will have a role, but it will be a niche one. If this analysis was compelling, subscribe to Business Undercurrent. We analyze the technologies shaping our future, and we aren't afraid to challenge conventional wisdom.